In this video, we're going to be discussing frequency distributions. We've already discussed frequency distributions for qualitative data, for the categorical data. What we're going to do in this video is discuss frequency distributions for that quantitative data, that numerical data that we want to look at. And you'll notice here that it says the first step in summarizing your quantitative data is to determine whether the data is discrete or continuous. Remember that discrete variables, discrete data, are those that have specific values. It may be whole numbers. It may be, well, I can only purchase a pizza in 6 inches, 8 inches, 12 inches, or I can only purchase bolts in a certain length. This is discrete data. Now, don't get me wrong, bolts can come in 3/8, 5/8, things of that nature, but they can't come in other sizes at times. You can get them custom, and so that brings up a whole different can of worms. So we're going to concentrate on discrete data for right now. When we use discrete data, basically we do still have what we call classes or categories, but more often we have those when they are continuous variables. For discrete data, normally we just create a category for each individual value. So let's say the number of people, 0, 1, 2. Those are our different categories or our different classes. And so where we want to organize the data, remember in qualitative data, we had the frequency distribution where we did the tally, and then we did the frequency, and then we calculated the relative frequency. We do the exact same thing here. So looking at this data, it says the following data represent the number of available cars in a household based on a random sample of 50 households. Construct a frequency and relative frequency distribution. So think about in a household, how many cars are possible. In this particular sample, we had anywhere from 0 cars up to 5 cars. So I've got 0, 1, 2, 3, 4, 5. A big key about discrete data is these values right here. Even if I didn't have any 3s, I need to put it. That's actually with any quantitative data. I can't skip values. If that is a possible value. So if 3 wasn't even a possibility, then I could skip it. But I cannot skip it if it is even a possibility. Which in this case, yes, 3 is definitely a possibility. When we're creating the frequency distribution, remember from qualitative data, we went through and counted the number of M&Ms that we had. We said, okay, here's one brown M&M, here's one red M&M, here's one blue M&M, here's another brown, here's a yellow. And we did tally marks. The tally marks come in extremely handy when you're looking at larger data sets. Small data sets isn't as bad, but larger data sets, because I get lost. Did I count all of my 3s? Did I count all of my 2s? I'm not sure about you, but I definitely get lost. When you receive a set of data and are trying to organize it, identify your possible values and then go through and count using these tally marks. For example, 3 is here, 4 here, 1, 3 again, 2, 0, 2, 1, 3, 3, 1, 2, 3, 2, and 2. And we do this for all of our values. I recommend that you pause the video and finish counting these up yourself to see if you receive the same number of each possible outcome that I did. Oh, nope. I received 4 values for 0 cars, 13 values for 1 car households. I actually counted 22 values for 2 car households, 7 for 3 cars, 3 for 4 cars, and 1 for 5 cars. Once I have these tally marks, remember, we count them up and we make our final number in the frequency column. We actually would like a numerical number here. This way we can quickly glance at it and see our data. I would like to add up this frequency, and so when I add it up, hopefully I get the 50 that it tells me that I have. And in this case, yes, I do. Why did I need the total frequency? Because I used the total frequency to calculate the relative frequency. Remember, relative frequency is the frequency divided by the number in your sample size, n. When I calculate for 0 cars, I calculate 4 divided by 50, that is 0.08. Go ahead and do your other calculations and check to see if we receive the same numbers. I calculated 0.08 or 8 hundredths for 0 cars, 26 hundredths for 1 car, 44 hundredths for 2 cars, 14 hundredths for 3 cars, 6 hundredths for 4 cars, and 2 hundredths for 5 cars. Hopefully, you calculated the same item. Recall back from our qualitative data, we created a frequency distribution, we calculated the relative frequency, then what did we do with it? We graphed it. We graphed it in some type of manner. For qualitative data, what we tend to look at is a graph called a histogram. A histogram is very similar to a bar chart. You still have what we call class now on the horizontal axis and the frequency or the relative frequency on the vertical axis. The difference with a histogram from a regular bar graph, first of all, it's for quantitative data instead of qualitative data. Secondly, we want to make sure that the bars touch each other. If you recall, whenever we looked at just a regular bar graph or a Pareto, there was a little bit of a gap. The reason there's a gap there is because we're talking about categories. Brown, yellow, red, they're different colors. There's no consistency as to the order, and also there's no possibility of an overlap or anything of that nature. There can actually be colors that aren't on there. That could be a mixture of 2 colors. Therefore, we do not put the bars touching each other. In a histogram, Notice here I have the possibility of 0 cars, 1 car, 2 cars. Can I have the possibility of half a car? Okay, now some of us may have grown up with a car that did not run or that was all parts or something of that nature. But in our cases that we're really talking about number of cars in a household, no, we cannot have half of a car. So there's nothing in between that we can have. So you either have 0, 1, 2. That also makes it discrete. Therefore, for quantitative data, we want the bars to touch. Example 2 would like for me to draw a frequency and a relative frequency histogram for the number of cars per household. You will notice I already have these set up. You'll notice that I have titled the graph Available Cars in a Household. I have also labeled my horizontal axis with number of cars and my vertical axis either with frequency or relative frequency. Please be sure that you label these accordingly. We are currently working with discrete data. You are either 0, 1, 2, 3, 4, or 5. You're not in between. When we go to graph these, the bars still represent our height. I'm going to bring this one up to about 4 over the 0, and I think I made that a little bit too short. So too narrow. Then for 1 car, we had 13. I'm just going to connect it with this one and draw it up. And notice that I'm putting it over the number. It's because there are 13 that are exactly 1. There are 4 that are exactly 0. There are 22 that are exactly 2 cars. There are 7 that are 3 cars. There are 3 that are 4 cars. And there is 1 that is 5 cars. Again, I didn't overlap, but I connected the bars to each other. I also put them directly above the different numbers. You will notice when we get to continuous data, there's a slight difference here. But for discrete data, we put them directly over the bars. Relative frequency is the exact same thing. It's still a histogram, the bars touch. The only difference is that I'm using those relative frequencies that I calculated instead of the actual frequency. For example, 0 cars was at a 0.08. 1 car was at a 0.26, so a little bit above here. 2 cars was at 0.44, so just below the 4-5 line. 3 cars was at 0.14, so just underneath here. 4 cars was at 0.06, so just above this line. And then 5 cars was at 0.02, so we're down here. You will notice that when you look at the difference between a frequency histogram and a relative frequency histogram, that the bars correspond in height order, okay? This is because it's the exact same data. The bars are relatively the same height as well. That's because this is the same data. Therefore, the graphs should look the same. The difference is we're using relative frequency compared to frequency. You will also note that we started at 0 on our vertical axes for both. We counted each line by the same increment. Here I counted by 5s. I did not start at 4, 13, 14, 18, I count by the same number. It needs to be evenly spaced. So I would like for you to work on organizing discrete qualitative data. Let me know if you have any questions.